Okay, this video is going to be on our first lecture topic for biochemistry. Biochemistry is the basics of biology and chemistry kind of merging together and fitting together. So I want to start with a little bit of review from last year. This is probably some stuff you've heard before. It's on elements, molecules, atoms, that type of stuff. So we're going to start with elements here. This is a rough drawing of the periodic table. The ones that we talk about most in this class are hydrogen, carbon, nitrogen, and oxygen. So the letters represent where they are located on the periodic table. Obviously hydrogen's H, carbon's C, nitrogen's N, oxygen is O. Some of the others we look at are calcium, potassium, sodium, and you'll see those later on here too. Everything's made up of elements. So everything we talk about in this unit is made of elements. So the elements are a collection of what we call atoms. So for example, C, carbon, is a collection of carbon atoms. N is a collection of nitrogen atoms. O is a collection of oxygen atoms. And H is a collection of hydrogen atoms. Now atoms can be broken down into even smaller things. Atoms can be broken down into electrons, the nucleus, neutrons, and protons. Now protons are very important. They're positive. They're positively charged. The opposites of protons are electrons, which are negatively charged, and we'll see that later on in some chemical bonds, that the charges of these make a big difference. Protons have a mass of 1, where electrons basically have a 0 mass. Their mass is very small, and we hardly ever need it for calculations or values. So protons and electrons are kind of the opposites. Protons are in the center part of the atom, called the nucleus. Electrons are in kind of an orbit around the nucleus, so they're spread out. Now the nucleus is made of protons and neutrons. Neutrons have no charge, they're very unreactive, and they have a mass of 1 as well. So when we look at total weight, the two things that have mass are neutrons and protons, total weight. And you probably worked on that last year a little bit in 9th grade. So you'll see how those are important here later on. So talking a little bit about chemical bonds. Now this is 2 carbon atoms here. The carbon nucleus in black, and then you can see the little green dots connected to their orbit in green there. Those are the electrons in green. So the first type of chemical bond I want to talk about, and the most common one in terms of biology, is called a covalent bond. When 2 atoms, carbon atom, share electrons that bind them together, that are binding. So there's pairs of electrons here that those atoms share. So this would we call a double bond because there's 2 of them. Now we might only see a single bond where there's only 2 electrons being shared and one circle around them. So we see different types of bonds here. That's not overly important. What you want to know is that covalent bonds are sharing of electrons, and they're the most common ones. So when we structure this thing all together here, this is an example of a bunch of bonds coming together. So we have this molecule called glucose. So glucose is a molecule that's made up of atoms. So glucose is a sugar that we eat and we use for our cells for energy, as we'll see as we go through this unit. The chemical formula for glucose is C6H12O6. So what that means is there's 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Now the structure of it looks like this. The thing with sugars is they're typically noted by a ring. So you can kind of see a ring-like structure here. The red are those electrons that are being shared, the bonds part of it, the chemical bonds. So this carbon's bonded to this carbon, to this carbon, to this carbon, to that oxygen, to that carbon in a ring structure. And you have some stuff branching off, as you can see. But if you total them up, you'd have 6 carbons, 12 hydrogens, and 6 oxygens. And that's the structure of glucose. So that's a molecule. Atoms can sometimes change into ions. So atoms can change into ions. And ions are in atoms with a net charge, a positive or negative. So here's an example. This is a nitrogen atom here. And I haven't drawn the orbital in. Hopefully that doesn't confuse you too much. But the 7 electrons are these purple dots, and you can kind of see them in an orbital shape there. Here we have the nucleus. It has 7 protons. And since we're not concerned about the neutrons very much, the green dots, I didn't even put them on there because they have no charge anyway. So protons and electrons are the only ones that we're concerned about. So when you have 7 pluses and 7 negatives, that is a 0 charge. Now, nitrogen typically gains 3 electrons. That's its common ionic form. So what that looks like then is very similar structure, except now we have 10 red dots that represent 10 electrons that are negative. We have 7 protons still, because all we did was add 3 electrons. They gained 3 electrons. So our net negative charge is -3. So now that nitrogen ion will interact differently with a neutral nitrogen atom. You can probably understand that this negative charged ion would interact with something positive. And that's how we have ionic bonding. So ionic bonding is when ions combine together. And so a great example of this is NaCl or table salt, a common food thing you put on food every day. So in table salt, it's first to talk about all atoms have a common ion. So for example, sodium, the atom, will commonly change into sodium plus ion. Chlorine, which is Cl, will commonly change into Cl minus the ion. And so when these things start to stick together, what typically forms is something that looks like this. We call it a lattice structure, not too important. But you see that a positive is attached to a negative, negative to a positive, positive to a negative, negative to positives. So the negatives are surrounded by positives, and the positives are surrounded by negatives. So this positive has negatives on each side of it. Okay, and same with these corners. And so we end up coming up with a generic formula of NaCl. Now, you'll kind of see the structure here. If you looked at a table salt under a microscope, you'd notice it was cube-shaped. And that comes from how these interact with each other and form. Just a few other common ions. Oxygen, we'll use this a little bit. Oxygen is generally a -2 charge. Nitrogen is generally a nitrogen -3. Calcium is usually 2+. And potassium, K, is usually a K+ charge. So the charges always want to balance out too. That's the last part of it. So that's it for this part. This is just an intro to biochemistry. So make sure you go on and take the short quiz after you're done.